language L is equal to, if you want, I will give some name also, L1 to differentiate. L1 is equal to, everyone listen, A power n, B power n, C power n, where n is greater than or equal to 1. Everyone listen, A power n, B power n, C power n, where n is greater than or equal to 1. Can you say in this language, you only say, in this language, all three will be equal? In this language, all three will be equal? Yes. Right? See this one. A cube, short way of writing. A cube, B cube, C cube. Right. Next one. A5, B5, C5. Next one. A20, B20, C20. A5, B5, C20. No. All should be equal. Next one. A20, B30, C40. No. Next one. Only A's. No. Only B's? No. Only C's? No. Next one. A's followed by B's? No. See, all three should be there. Sir, A 20, sir. C also 20, sir. What is the problem? A is equal to B is equal to C. B is not there. So wrong. Now, are you okay with the problem? Are you okay with the problem? Yeah, if you okay with the problem, listen, if you okay with the problem, I will try with one stack. See the problem. Listen, I will try with one stack. Everyone listen. If you okay with the problem, I will try with one stack. See this one. A5, B5, C5. A5, B5, C5. I will try with one stack. A5 means what? 5 A's. One time listen. 5 B's. 5 C's. Right? Remember, starting also dollar there, ending also dollar there. Otherwise, if markers not there, listen, every game required marker or not? Every game required marker or not? If marker not there, what purpose we are trying here? There should be a marker for everything. Can you help to know? You've seen the old people? Old people, they have to die or not some point of time. Old people, some point of time, they have to try, they have to die or not? They have to die because they cannot walk. They cannot eat also. Are you getting? Old people, some old people, if you observe, right, they cannot eat, they cannot go to washroom their own. That is the reason everything needed expiry. Everything needed expiry. So you, right, listen correct now. GATE exam also having expiry. Right? GATE exam day is the expiry date. After that date, you don't talk. This class also having exit. At 8:30, class will stop. So I want to say that marker required. If marker not there, if no limits, what is the meaning, right? We don't have infinite resources. We don't have infinite resources. We have only finite resources. We have to utilize efficiently. Right? So I seen some old people. I felt so bad. Instead of living like this, it is better to die. That is the reason God kept one more keyword, right? Birth also, death also. If not there, I think it is very painful to see, right? Old people suffering like that. Washroom also, you have to ask the one of the family member. They will shout on them every time. Who will come? So I felt, this is something like this. So that is the reason God kept the some expiry date also, right? But anyhow, that is none of my business. I have nothing to do in that, right? I'm really sorry. Can you come here? Listen, can you come here now? Can you come here? Can I come here? Say yes. Can I come here? There's nothing what we can do. God created, God is taking. Just leave that part. Come here. Right, now see everyone. So string is starting marker, ending marker. Now careful everyone. PDA means we have one stack. Listen, PDA means one stack. Take one stack. Initially dollar there. This dollar keep. Okay, I kept. Now listen everyone. Everyone listen. Now listen everyone. See this one. A's are coming, push in the stack. A's coming, push in the stack. A's coming, push in the stack. 5 A's, so 5 push. 5 A's, so 5 push. Until now, fine. I am writing the code also. A push. A push. A push, like that going on. A push, like that going on. 5 times done, it's okay. Okay. All A's are push. Perfect. Until now, perfect. All A's are pushed. Now listen. B is coming. Everyone listen. Everyone listen. B is coming. Everyone listen. Every B, pop A. For 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 every B, pop A. Right? Let me write now. B, pop A. B, pop A. B, pop A. B, pop A. So it's keep on going. B, pop A. Now let me ask, B, pop A, it's okay. Listen, A's and B's are both cancelled each other or not? A's and B's are cancelled each other or not? A's and B's are cancelled each other. With whom you will compare with C's? You have to compare C's also. With whom you will compare C's? C is asking, what should I do now? C is left. Can you help me? You have to compare all 3 people or not? A is equal to B is equal to C's. You are not bothered anything about C's. A is equal to B is equal to C's. You are not compared with even you didn't see C. A and it is something like this one. There are 3 people. There are 3 people. A, B only compare. C left out. Then how it is A power n, B power n, C power n? So C left out. That is the reason. That is the reason. Remember, listen. Remember everyone. L1 is equal to A power n, B power n, C power n, where n is greater than or equal to 1. Finite automata not possible, you know. PDA also not possible. What does it mean? 1 stack, you cannot solve it. 2 stacks required. Now see this one. Finite automata plus 2 stacks is known as Turing machine. Finite automata plus 2 stacks is known as Turing machine. Another way of writing same thing. Listen, another way of writing same thing. PDA plus 1 more stack extra, which is also Turing machine. Because PDA internally contain finite automata plus 1 stack. That is the reason. Now some people are asking, sorry, using 2 stack, can I do it? You can see. Listen, you can see this one. Listen, 5 A's, 5 B's, 5 C's. Dollar here, dollar here. Now see, 2 stacks I'm taking. Remember everyone, every stack having some marker. Every stack having everything needed marker. 2 stacks or 2 marker. Now see how I am doing. Everyone listen, see how I am doing. See how I am doing. See the answer. A coming, see the answer. See the answer. A coming, push in both the stack. For every A, push in both the stack. 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 Until now, perfect. All A's were. I'm writing also. A, push both. Push in both the stack. A, push in both the stack. A, push in both the stack. A, push in both the stack. Continue. A, push in both the stack. Continue. Okay. Fine. Now see the story. Now see the story. Now see the story. What is the answer? Listen, for every B, pop only first step. B, pop A in first stack. 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 Continue. B, continue like this. Okay. So then for every B, cancel. For every B, A cancel. For every B, A cancel. For every B, A cancel. Now see the interesting answer. B is over. Can you help? B is over. After B, C coming means what? B is over. After B, C coming means B is over. When I got to know B is over, I got dollar. B is over means dollar. A is also over. When I got to know after B, C coming, so B is over. B is over, I got to know dollar. A is also over. Oh, A is equal to B. That is the indication. Now see the answer. For every C, pop in the second. C, pop, second stack. C, pop, second stack. C, pop, second stack. C, pop, second stack. Continue. C, pop, second stack. Continue this. So for every C, cancel. 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 C is over. What does it mean? Dollar came. Right? Here also dollar. Oh, A is also over. That means A is equal to C is also I compare. When I got to know C is over, I got to know A also over. So A is equal to C. When I got to know B is over, A is also over. Then A is equal to B. That means A is equal to B and one more. A is equal to C also. Indication that A is equal to B is equal to C. That is the indication. Two stacks. To solve this problem, two stacks required. Finite automata plus two stacks is known as Turing machine. Now it is the correct time to ask you. Listen, it is the correct time to ask you. It's the correct time. What is the language? L1. See this one. L1. A power n, B power n, C power n. Where n is greater than or equal to 1. This one, regular fail. Means finite automata fail. So regular fail. Next one. CFL also fail because PDA fail. Because PDA fail. Next one. To this one. Right? What is the answer? It is a REL because Turing machine pass. That is the reason many machines are there. Don't waste unnecessary resources. For smaller problem, why two stacks required? For the middle problem, why two stacks required? Complex problem, take more space, no problem. See, two stacks means two resources you are taking. Unnecessarily, why you take? Bigger problem you take. Smaller problem, go with smaller machine. Some people are asking, sir, where is the LBA, sir? LBA theoretically present, practically not there. LBA theoretically present, practically not there. Right? LBA, Turing machine, both are similar. Minor difference there. Afterwards, I will say. I'm repeating once again. LBA, Turing machine, both are similar, but minor difference is there. Minor difference. We will discuss afterwards. Okay? Is it okay? Can you help me know? What is the topic name? Can you help me know? What is the topic I written? Can you see this one? Before starting, I said one topic. What is that one? See this. See this one. Why these many automatas? This is the topic. Why these many automatas? I want to give clarification. Why? Smaller problem, smaller languages, smaller machines are enough. Bigger problems, bigger machines required. For this machine, PDA required. For this machine, Turing machine required. For this machine, Turing machine required. Now, I will summarize the today's class. With this, we can end. Now listen. Let me give some numbers. Language, listen, language L1. I am writing the some other name. Language L1, A power M, B power N, where M comma N greater than or equal to 1. Next one, language L2, A power N, B power N, where N is greater than or equal to 1. Language L3, A power N, B power N, C power N, where N is greater than or equal to 1. Now careful everyone. This is the today's conclusion. Today's class conclusion is this. Carefully everyone. In this language, A's, B's you have to compare or you don't want to compare? In the first language, A's, B's you want to compare or you don't want to compare? In the first language, A's, B's you want to compare or you don't want to compare? Remember. See this one. No comparison. No comparison means finite automata possible, means regular language. Careful. If no comparison, finite automata enough. No stack, nothing required. Comparisons are there, then only stack required. No comparison. Finite automata saying I can handle. So it became a regular language. Now see the answer. Is there any comparison here? Is there any comparison? Yes, see this one. See this one. Comparison there. Comparison there. Comparison means finite automata saying I cannot. PDA saying I will handle. Don't worry. So it became CFL. Right? Fine. Now listen. Can you help me now? In the third language, one comparison or two comparison? In the third language, one comparison or two comparison? Remember here comparison there, but two comparison. Two comparisons. Here one comparison. Finite automata fails, but PDA saying one means I can handle. But here two comparisons. Two comparisons means finite automata saying I cannot. PDA saying I also cannot. With one stack, I cannot do two comparisons. Then I think a Turing machine saying I can handle. So it is a REL. Remember, comparison means finite automata gone. Next one, more than one comparison means PDA gone. So I'm saying, I'm writing here. Note. Comparison. Then who will go? Comparison exists. Then finite automata saying I cannot handle. Next one. Finite comparison exists means finite automata saying I cannot handle. Next one. More than one comparison. More than one comparison. Then what is the answer? Comparison means he will go. More than one comparison means PDA also gone. So Turing machine is the only hope. Someone is saying more than one comparison means, sir, if two comparison, Turing machine perfect. Sir, if at all three comparison, Turing machine perfect. Next one, sir, if at all four comparison, Turing machine perfect. It doesn't matter. Some people are asking, sir, how it is possible? Remember, with the two stacks, you can do whatever you want. I'm writing with two stacks. With two stacks, you can do whatever you want. Now, it is a correct time to ask you. Stack and queue both are opposite? Stack and queue both are opposite or not? Stack is last in, first out. Queue is first in, first out. Stack and queue both are opposite. Am I right or not? Remember, listen, remember, with the two stacks, you can do whatever you want. What is the meaning? With the two stack, you can do queue also. With the two stack, you can do whatever you want. That means with the two stack, you can do queue also. That is the reason in the interviews, people will ask you, how can you implement queue using stack? Or take two stacks, you can do it. Using two stacks, you can do whatever you want. Right? So if anyone asks you from today onwards, can you implement queue using stack? Oh, you want using stack queue. Take two stack, everything possible. Take two stack, everything possible. With two stacks, you can do whatever you want. That is the reason Turing machine is the ultimate machine. Turing machine is a saturated machine. Let me write. That is the reason Turing machine is Saturated machine. That means if Turing machine cannot do, no other machine can do. Turing machine is a saturated machine. If anything computer can do, Turing machine also can do. Next one, let me write now. Turing machine can do means computer also can do. Right? Next one, computer can do means Turing machine also can do. But comparing both of them, who is the superior? Human. Can you help, Can you help, With the two stacks, you can do whatever you want. So Turing machine is a saturated machine. Turing machine can do means computer can do. Computer can do means Turing machine can do. But one thing, comparing this story, human having more power or not? The only thing Turing machine cannot do, the only thing two stacks cannot do is human emotion. If mama cry, computer cannot cry. If mama is crying, computer cannot cry. Can you help, See everyone. My enemy is crying. Should I cry or laugh? My enemy is crying. Should I cry or laugh? Laugh. Because he's your enemy. My mama is crying. I have to cry. Computer cannot do. Computer, right? If I say to the computer, if anyone cry, he will cry. It doesn't matter whoever he is. It doesn't matter whoever it is. Right? So that's the meaning of human emotions. Right? Correct time. Correct time. Correct time crying, correct time laughing, something like that. So the only thing is that the only thing what computer cannot do is human emotions it cannot do. It will do all other things. See, with the two stacks, you can do everything, whatever possible by computer. You cannot do human emotions. That is perfect. So today's topic is how many automatas? Listen, today's topic is how many automatas? Next one, how many formal languages? What is the relation between them? What is the relation between all the automatas? Why these many automatas? You got clarity? Today's class purpose is how many automatas? What is the relation? Next one, how many formal languages? What is the relation? Why these many automatas? Which one having more power? Which one having less power? How power is came? Stacks are increasing, power will increase. Now, one big question I want to ask you. Can anyone help? Finite automata plus one stack. Finite automata plus one stack is less powerful than finite automata plus two stacks. Am I right or wrong? Is it right? Yes. Now see this one. Finite automata plus two stacks is less powerful than finite automata plus three stacks. Is it right or wrong? Finite automata plus two stacks is less than finite automata plus three stack. Remember, with the two stacks, you can do whatever you want. Why one more stack? Right? It is wrong. Remember, these two are actually equal. Right? This is correct. Finite automata plus two stacks equal to finite automata plus three stacks. You can do whatever you want means why are you taking one more? Next one, only for namesake. Finite automata is less than finite automata plus one stack. Am I right? Right? Perfect. So this may be right. Check true or false. First statement, second statement, third statement, fourth statement. Right? So first one is true, third one is true, fourth one also true, only second one fail. True or false. So remember, this subject will give many logics to you. TOC subject and algorithm subject, both are logics. Both will build logics to you. It will make you more strong in the logic. Please study these two subjects. properly you study these two subjects, you will become so good in computer science. Afterwards, programming nothing. Afterwards, programming is nothing. Please study TOC properly. Please study algo properly. Then computer science becomes so easy. To make it some more good, discrete mathematics also. Both are all three similar, as I mentioned to you. Algo, discrete mathematics, and one more TOC. All similar. Different way of saying, different logics. They will teach different logics to you. Algorithm, right? In terms of programming, they will do programming kind of behavior. TOC will do in terms of machine, but both improving logical skills. Algo will improve logical skills. TOC will also improve logical skills. Discrete mathematics also will improve logical skills. All three will improve your logics. After these three over, programming nothing. You can easily handle programming. Any language you can learn easily. These three are over. Any language you can learn easily. So your goal in this year, not rank and all, gaining as much knowledge as possible.